The edge of our observable universe, the farthest place we can ever see, shares a strange, almost perfect connection with something else, the event horizon of a black hole. That invisible line, a point of no return even for light? Now, what if it's not just a weird coincidence? What if it's a clue? What if our entire universe is inside a black hole that exists in another much larger universe? This isn't just some wild thought you get at 2 a.m. It's a serious scientific idea born from places where our best theories break down. For decades, we have believed the universe began with Big Bang, an explosive birth of space and time. But there's a problem. The math doesn't hold up at the very beginning. The physics, it just stops working. So what if the Big Bang wasn't the beginning? What if it was a transformation, a birth inside a cosmic structure that already existed there? Today we'll explore the mind-bending clues that suggest our reality may be trapped within the gravitational grip of a colossal black hole. From deep mathematics to strange, unexplained data, we'll follow the evidence and uncover what it could mean for space and time and the true nature of our existence. Before we get into this wild theory, we need to get our head around 3 big ideas: Big Bang, black hole, and the edge of our universe. First, the story all we know, the Big Bang. For about a century, this has been the bedrock of cosmology. It says that around 13.8 billion years ago, our universe burst into existence from a single point. And that single point was incredibly hot and incredibly dense. From there, the space itself started expanding, carrying everything with it. As it expanded, it cooled, and first atoms were formed, then stars, galaxies, and eventually us. Now, this model is incredibly successful. It explains why the universe is expanding. It predicted the afterglow of the creation we call as cosmic microwave background. And it even nailed the amount of lightest elements we see out there. But the Big Bang model has a huge puzzle at its core: the singularity. According to Einstein's theory of general relativity, if you run the clock backwards, everything in the universe squeezes into a single point of infinite density. At that point, our laws of physics breaks. An infinity in physics equation is just a big red flag. It tells you that your theory is missing something. It's like the first page of the cosmic history book ripped out. And physicists, they have always been bothered about it. They have seen this as the fundamental problem to be solved. Now let's talk about black holes. A black hole is what you get when gravity completely takes over. It's a spot in space-time where matter is crushed so tightly that the gravitational pull becomes inescapable. Nothing, not even light, can get out. A black hole has 2 main parts. At the very center is one of those pesky singularities, a point of supposedly infinite densities, where physics breaks down. And around that singularity is event horizon. Event horizon isn't a solid surface or a gate. It's an invisible boundary. It's one-way door in the space-time. Once you cross it, even if you're light, you can't ever come back. And it is literally the point of no return. And that brings us to the third piece of this cosmic puzzle, the edge of observable universe. Just like a black hole has an event horizon, a point beyond which nothing can escape, our universe has something similar, a cosmological horizon. It's not a wall, not a barrier you can touch. It's simply a limit of what we can see. Why? Because the universe is about 13.8 billion years old. Anything beyond that, light is still on its way. Now, this cosmological horizon marks the boundary of everything that we have ever received information from. Beyond it lies the unknown. And this is where things get weird. Black hole's event horizon holds information in. Our universe's cosmological horizon holds everything out. So one thing holds in, the other keeps things out. But if you were on the inside, they might seem surprisingly similar. The symmetry between black hole's interior and our universe's exterior is what has sparked this whole radical idea. What if it's not just a neat comparison? What if they are somehow same thing? Okay, now with basics covered, let's jump into theory itself. It goes by few names: black hole cosmology or the black hole universe, but the idea is simple. Our whole universe is inside of a black hole that exists in a bigger, older parent universe. Now, this isn't just a random guess, it's an attempt to fix that huge problem with singularity in Big Bang. Black hole universe theory suggests that when a supergiant star in a parent universe collapses, it doesn't form an infinite dense point. Instead, right before singularity can form, the rules of quantum gravity are thought to take over. Theories like loop quantum gravity suggest you can't squeeze matter into infinitely small point because space-time itself is made of tiny invisible chunks. When collapsing matter hits the maximum possible density, it cannot be compressed anymore. So instead of forming singularity, it bounces back. Now think of it as compressing the spring as far as it can possibly go. And all that stored energy has to be released. In this cosmic version, the compressed matter and energy rebound in massive expansion, creating a new growing region of space-time on the other side of the event horizon. That means a whole new universe. From inside, this event would look exactly like a Big Bang, a moment of incredible heat and density, followed by rapid expansion. Now, this completely changes the story. Our Big Bang wasn't just the beginning of everything from nothing, it was a transition, a birth of a baby universe from matter collapsing in parent universe. Our universe is just one descendant of cosmic family tree. This idea neatly gets rid of singularity. It's no longer a breakdown in physics, but physical process. Our universe didn't start by breaking laws of nature, but because of them. So from outside, in this parent universe, we just look like a black hole. From inside, we are expanding universe. Black hole's event horizon is our cosmological horizon, the edge of what we can ever see. We are living inside a no point of return. It's a wild idea, but is there any evidence for it? Now buckle up. We are about to get into some of the most fascinating and debated clues in all of cosmology. If this is already making you rethink, take a second to subscribe and hit the notification bell because you won't want to miss where this investigation goes. Okay, any good theory requires some good evidence, and the black hole universe has few interesting lines of reasoning. Now, these aren't definitive proof, but they are observations that point to a very strange direction. First clue, it's a calculation so simple yet so stunning, it's almost impossible to ignore. Back in 1916, Carl Schwarzschild came up with a formula, a way to calculate the radius of something we need to shrink it to in order for it to become a black hole. He called it as the critical radius. For Sun, that critical radius is about 3 kilometers. Compress all that mass of a sun into that size, you have got yourself a black hole. For Earth, even smaller, roughly the size of marble. Now, the weirdest and most interesting part. If we apply the same formula to the entire observable universe, cosmologists have estimated that the total mass of everything we can see, all galaxies, stars, planets, dark matters, radiation, all of it, when physicists plug that enormous mass into Schwarzschild's equation, they get the radius of, wait for it, 13.7 billion light years. That would sound very similar because the size of the universe is 13.8 billion light years. That's the same radius of observable universe. Now think about that for a second. Actual measured radius of observable universe, the distance to our cosmological horizon, both of them is 13.8 billion light years. The numbers line up almost perfectly. The size of our universe would need to be a black hole is the size of our universe is. To many scientists, this is likely fascinating coincidence. But for those who support this theory, it's a powerful hint. It suggests that the reason our universe seems to have this critical density that makes it flat is because it has exact mass to radius ratio of a black hole. In this view, it's not a coincidence at all. The second clue is newer and far more controversial. According to our best cosmological models, The universe should more or less look like same in every direction. The galaxies should spin randomly, some clockwise, some counterclockwise, but they should be in equal number to balance each out. But recent data suggests something strange. Astronomer Lior Shamir from Kansas State University analyzed thousands of galaxies, and what he found was an imbalance, a subtle but statistically significant preference in the spin direction of galaxies across different parts of the sky. In certain regions, more galaxies appear to spin one way than the other, and that shouldn't happen. So, what could cause it? Let's be clear. This is a freshly and fiercely debated result. Observational errors or data biases or other effects could still explain it. But there is a wilder possibility, one that fits eerily well with black hole universe idea. What if the entire universe is spinning? If the black hole model is true, this isn't science fiction. Black holes often form from spinning stars, and it inherits that rotation. If our universe was born inside a black hole from a larger universe, it might have inherited its parent spin. In that case, those swirling galaxies, they might be whispering the rotation of a much bigger cosmos, one we may never see. So if our universe was indeed born inside a rotating black hole, it might have inherited that spin, creating a subtle preferred axis that could influence how galaxies form over billions of years. Now, this is far from proven, but it's a kind of unexpected signal you might look for if our universe was born inside a spinning and dynamic object. Clue number 3. Our third clue re-examines the most famous piece of evidence of the Big Bang, the cosmic microwave background. In standard model, CMB is the leftover heat from Big Bang itself, but the black hole universe model offers a different take. What if CMB is actually a thermal remnant of parent universe? When matter falls into a black hole, it heats up and releases radiations. In this model, the matter and energy that collapsed to form our universe would have reached a uniform temperature before the bounce. The bounce would have stretched that thermal energy across our new universe. The incredible uniformity of CMB, which is actually a bit of a puzzle for the standard Big Bang model, becomes a natural outcome here. The universe started uniform because it was born from matter that had already settled into consistent temperature in the parent universe. Okay, our final clue. It's not mathematical or physical or observational. It's more sort of a philosophical clue. It touches one of the deepest mysteries in science. Physicists have noticed something strange. The fundamental constant of nature, like the strength of gravity or mass of an electron, seems perfectly tuned to allow stars and planets and life to form. Change them even slightly, the universe will become lifeless and sterile and nothing would exist here. No galaxies, no chemistry, no people. Now, Big Bang model doesn't explain this. It just says that's how things are in this universe. But what if there's a deeper reason here? Physicist Lee Smolin proposed a radical idea, cosmological natural selection. What if every black hole gives a birth to new universe? And what if the physical constant in that baby universe are just a little bit different? Imagine this happening over and over again, a kind of evolution. Which universe reproduce the most? The ones that make the most black holes. Now, how do you make lots of black holes? You build stars, massive ones, which means you need a universe with right physics. And that also happens to allow complex atoms and molecules and even life. In other words, our universe might be fine-tuned not for us, but for making black holes. And we might just be a beautiful byproduct of a universe designed to make black holes. Okay, a good investigation looks everything at all angles. Now, this theory has some serious challenges. Black hole universe idea is on the fringe of cosmology for a very good reason. Biggest issue is the lack of direct and testable evidence. And this is the heart of the problem. By its very nature, the theory is very hard to prove or disprove. If we live inside a black hole, the event horizon acts as a perfect wall, and we can't get any information from the parent universe outside. Now, we can look for clues inside our universe that are consistent with the theory, but we can't find that one killer piece of evidence to confirm it. Now, science depends on predictions that can be tested, but this theory makes predictions that cannot be tested. Now, second, we can't ignore the massive success of Big Bang Theory. It's not just a wild idea, it's a scientific model supported by mountain of precise observations. It predicted the cosmic microwave background, the faint afterglow of early universe. It explains the expansion of space so well. We can measure it down to a fraction of a percent. And its math on how light elements like hydrogen and helium were formed, it matches exactly what we see in the cosmos. And the new theory, no matter how bold, has to get everything that Big Bang has already got right. Plus, it has to fill in the gaps without breaking what already works. And that is clearly a very high ask. Okay, and the third, the very mechanism that makes the theory work, the bounce and expansion, is still completely hypothetical. While theories like loop quantum gravity explains that a bounce should happen, we don't have a proven theory of quantum gravity yet. What really happens at the center of a black hole is absolute black box. We have no idea about it. But until we do, the bounce theory is a clever but unproven assumption. So, this case is far from closed. Black hole theory offers elegant solution to some big problems, but standard model rests on a much stronger foundation of evidence. Okay, let's take a step back and ask, what if we really do live inside another universe's black hole? And the consequences are staggering. First, it would rewrite our origin story. The Big Bang wouldn't be one-time explosion from nothing, but a part of grander cycle. A moment of birth is not the beginning. Our universe wouldn't be a singular event, one chapter in vast cosmic book. Second, it would transform how we see black holes. No longer the monsters of space that swallows everything, but cosmic worms, gateways. Every black hole could be the seed of a new universe, with its own laws, its own stars, and its own story. Picture this, a multiverse is not a chaotic mess, but a living ecosystem, a cosmic forest, where black holes are the seeds and the universe are the trees. And third, it would shift our place in this grand scheme of things. If universes are born through a kind of cosmic natural selection, then our existence isn't a miracle, it's a pattern. It's a result of a system that favors universes like ours, ones that are good in making black holes. We are not the center, we are a leaf of a branch in an endless forest. And maybe, just maybe, everything we have ever known, space, time, even physics itself, might be local rules, temporary bylaws of our little pocket of reality. Reality that is tucked inside something which is much bigger and much greater. So what's the conclusion here? We have followed the clues and ended up with a wild possibility. The strange math of our universe's size and mass, the potential hint in the spin of distant galaxies, and the neat solutions to old paradoxes all point toward one incredible idea. We might be living inside a black hole, a big one. While the standard Big Bang model still is reigning champion of cosmology, this alternative is fascinating and seems to get more interesting with new discoveries. This leaves us with one final question. If the universe is inside the black holes, what about billions of black holes in our own universe? Are they just crushing matter into nothing? Or are they womb or doorway into another universe? Is a black hole seed of another universe or another Big Bang? The investigation never really ends. What do you think? Does the evidence point to black hole universe, or is it all just an incredible coincidence? Let us know your thoughts in the comments, and if you want to keep exploring huge cosmic mysteries, make sure you're subscribed for the next one.